Hello and welcome to the Arkansas Division of Land Surveys. My name is Daniel Phillips. I am the state surveyor. Today we're going to look at post-processing ArDOT network data, GNSS data, and comparing it to RTK position and comparing that to an OPUS position. So the mark that we're looking at is in Benton County, actually on the Oklahoma state line, milepost 12. There it is. There's an estimated position for milepost 12. And this is in a pretty good clearing, so kind of ideal conditions for GNSS positioning. And we've got the point here in Carlson Survey. This is the RTK position. Staff surveyor obtained this yesterday. So, we want to look at how this compares to the post-processed position based on the same ArDOT network. This RTK position was obtained using a cell link to the ArDOT Arkansas DOT statewide network. So the first thing I want to do is open up my post-processing software. This is called RTK Lib. It is free to download. It's an open source software. Let me back up and show this step again. So when you download it, you'll unzip it and then go into the main folder. This is RTK Lib 2.4.3. Open that, go to bin, and the first thing I want to open is RTK Convert. Run. Okay, I have a lot of default settings, default file paths from an earlier project. I'm going to clear those out. Okay, so I want to convert the observation file to a format that can then be processed. I'm going to find the original file. Okay, this is milepost 12, and there's the observation file. So this was a 35-minute observation. Let's go back to the RTK converter. Now, I believe I could just drag and drop that to here. So that's the file that's going to be converted. Now we want an output directory, so I'm going to add some folders here just to keep everything in line. So I'm going to call this ArDOT actually, and I'm going to copy these files to here. On a rover file, base, and output. I'm going to move this again. So this is my rover data. Okay. So I'm going to copy this file path. Now in my output directory, I want my converted observation file to go into my newly created rover file. So I'm going to paste that file path. So that's it. So you don't change anything else here. So right now we're just converting the file. So down here, click Convert. Takes it a minute. Okay, that was successful. So everything stopped here. Now we have this OBS file, and that's what we're going to use for the next steps. Go back to my RTKlib folder. Now the next one I want to open up is RTK Post. Run. I'm going to clear out this default information from the previous project. Okay. So this is our converter. This is our RTK Post tool. Now, one thing I want to do here is plot this information, and I'm going to pull some information from that plot. Okay. Okay, I'm going to pull some information off of this graph now. I need to know exactly when my start time is, when the session start time was, and the session end time. So I'm going to write that down. So it looks like February 10th, 17:39 and 13 seconds to 18:14 and 57 seconds. We're going to need that later. In fact, right now. So in the post-processing tool, you'll need to enter the time and date of the session. So that's February 10th. (17:39 and 13 seconds). And you can open this and just type it in, actually. So February 10th again. End time of, I'm looking right over here, 18:14:57. Okay. Now I'm going to set my intervals to 1 second. Now I need to insert my observation file. This is the file that we just previously converted. So this is my rover folder. There's my OBS file. Just drag and drop and it will create that file path. Now we need to enter the base station data here, which we don't have yet. So let me show you how to get that. So this is ArDOT's website. I've already logged in. If you do not have an account to log in to this website, you'll need to call one of these numbers and talk to them about getting a subscription to access this data. Once you've done that, come back to this website, gps.ardot.gov. Then you'll log in and you'll be on the home page. Go to Sensor Map. So ArDOT has a lot of cores stations. So I'm going to pick the closest station to our project. So our project was just north of Siloam Springs. There is a station in Fayetteville which we're going to use. So click on that station and you're going to need the latitude, longitude, and height for later. In fact, I'll go ahead and enter that information in now before I download the network data. Okay, back down here to your RTK Post tool, go to Options. Now go to Positions. Now enter the lat long, so it defaults to whatever your last job was. So this is 36 degrees, 06 minutes, 56.85180 seconds. Longitude 94, 10, 48.13561. So I'm pulling it straight off of the information here. Now we need the elevation in meters. So it's set up right now, the latitude, longitude, and elevation, DMS format, elevation in meters. The ArDOT information defaults to meters in their height. So everything here is good. So that's 350.695. Leave everything else alone and hit OK. Now we need to download the base station data, which is going to come from this website. So let's maximize that. Okay. So over here on the left, go to Reference Data Shop, right here. Go to Start New Order, and I use the continuously operating reference station, top link. Now, at the bottom, I'm going to highlight, click on the station. Now go to time selection down here. Now this is where we use the information from the your rover data. So that's going to be February 10th. Start time. So this doesn't have to be exact, so I just give it a good healthy overlap. So my start time was 17 hours 93 minutes. So I'm going to call that start time of 17:30. Duration, if I give it a 1 hour duration, that gives me a good overlap to my ending time. My ending time is for this session is 18 hours 14 minutes. So this is going to capture everything between 17:30 and 18:30. Now I'm going to process this on 1 second intervals on my post-processing tool. Now set your interval for the data download to 1 second. So now it matches the setup on your post-process tool. Add to order. That's correct. Highlight that. Go to delivery options. Change this if you need to. Rhinex 2.11 works for my equipment. Now I'm going to select download data, generate data. So now it is processing. Order details. Now select it again and go to download. Alright, so this is going to put it default into your downloads folder. Now I'm going to copy this and place this in the file which I previously set up, base rover output. I'm going to place this in the base. Now we go back to our post-processing tool. Now we have the information for our base station. So the Rhinex OBS file is going to be your O file from the ArDOT information. So you drag and drop to create the file path. Now you'll need to add your navigation file. So I always start by putting the in file first, and then the G file second, and now specify where this information is going. So I'm going to put that in my output folder. So copy file path. This directory will be in the output, and I believe that is everything. So now just click execute. So it takes a little while, especially with those 1 second intervals. Okay, so it's done. So this is now the position file. Now what I do here, I've done that. You can obtain the position several different ways. This is just a text file. You can pull up a big long text file with all the lat and longs and find an average. But I go down here to the post-process tool and click plot. So this will give you a two-dimensional, it's basically an average, kind of shown in a geographic plot. And you can kind of see how far it drifts here. So looks like we've got 1, 2, 3, 4, maybe 4.5 centimeters east and west, and 1, 2, 3, 4, 5, 6, 7, 8 centimeters north and south. The center is going to be the average of all of those observations. So I'm going to just write down what that latitude and longitude is when I hover my mouse over the center. Okay, so let me write that down, and I'm going to convert that to northing and easting and compare it to my real-time position. So that's 36.32726919, and longitude is 94.59039867. Okay, let's convert that to Arkansas State Plane North. And I'm going to do that in NGS NCAT. Alright, so switch to, actually, stay on geodetic lat long, that's what it defaults to, and then enter the information, 36.32726919, longitude negative 94.59039867. Hope I got that right. Now pick your zone as AR North. I want to be careful to specify the zone. Since I'm right here on the Oklahoma-Arkansas line, it might default to Oklahoma. So that should be it. Now submit. And there's my northing and easting. U.S. survey foot northing, U.S. survey foot easting. So now I'm going to enter that into my Carlson project and compare it to this point. Copy the northing, manually input, enter assigned point, paste, got to get rid of the comma, easting, go back here, copy the easting, paste, and I know my elevation here is about 1162, so we're going to kind of put an estimate there. And there it is. So how close is this to the real-time position? Oop, I entered the name or the elevation as the name, so I made a mistake there. Block reference scale, we're going to make that real small so we can see the separation between the two. 0.1, okay. Kogo inverse. So we've got a separation of less than 1/10. So pretty good check. So in this case, if I did not have cell signal, which I did, this is a way to still obtain a position that's very close to, very similar to the real-time position. And just for good measure, I'm going to process the same rover data through Opus and just see how it compares. And I've got that right here. So I've got very good, this was, like I said, was open in a field, so I have very good observations used, 98%. My highest deviation was less than 1/10 of a foot in the y-axis. So I'm expecting very close position, very close to what we have. So here's the northing and easting. So I'm going to copy this. Go back to Kogo, enter assign point. Grab my easting. Paste. Elevation 1162. Description milepost 12. Opus. Okay, so there's where it falls. We'll make these all the same size and we'll take a look and compare. So I'll correct the name on this. Okay. So again, the separation between real-time position and post-process position is less than 1/10. Separation between the real-time position and Opus, about a 1/2, and the separation between Opus and the post-process point also less than 1/10. So very, very happy with that. So I hope this was helpful, and thank you very much for watching.